Hello, Cardstack community. Christy here. I'm the founding director of the Cardstack Project. Today, I want to introduce you to a very important piece of infrastructure we've been working on here at the Cardstack Project. It's called Gitchain. Gitchain is a very tricky piece of technology explained because nobody understands Git and nobody really understands blockchain. So you combine two things nobody understands, then the question is who else is left to understand it. So today I'm going to hope to express to you not only what we've been working on and why Gitchain is such an important piece of our vision of bringing the web to the 3.0 era, allowing application to be breaking to small component, what we call cards, and allow those cards to fluidly move between individual organizations and allow people to live self-sovereign life through these ownership of data and sharing with the people they want to care about. And a lot of the reasons we want to focus on this idea of using Git as a protocol is because with blockchain-based application, one of the big questions that people always ask is, does everything that you do in a website or in a web app belong to the blockchain? Do you write absolutely everything to the blockchain? I think it doesn't take very long for people to know, developers or even regular business people to say that's a bad idea. Writing blockchain information to blockchain is time-consuming, takes a long time, is very expensive, and is not very efficient way of storing a massive amount of data, especially as much data as it is to practically to put to run an application that people are going to be find comparable in quality and sophistication as what they're used to with centralized websites. So, my presentation today is called introducing Gitchain, and the subtitle of that is Gitchain is a chain-agnostic layer 2 application state synchronization and syndication protocol based on Git. That is a handful, but that's actually exactly what it is, right? So a lot of conversation has been about what does it mean to build, end-user, usable, scalable application using blockchain. And the number one technique that everybody's using is something called layer 2 architecture, which is that you build a layer that does not write everything to a blockchain. Most of the interaction goes into this layer 2. In our case, Gitchain is a layer 2 application protocol, and then some subset of that application state that's stored in this layer 2 protocol gets anchored onto the blockchain. And there's been a lot of different techniques and ideas about what kind of layer protocol could be. Sometimes let's have a faster blockchain, write data to a slower but more trustworthy blockchain. Sometimes it's building a payment channel, focusing the layer 2 just on payment type of transactions. Sometimes it's more generalized, like generalized state channel, like what counterfactual is doing, what seller network is doing. So what we're proposing here is uniquely about the type of application that you guys know about, which is content application, data application, something that is very familiar with people who are on the web. So we're going to talk about how this particular approach of Gitchain will allow us to achieve scalable application that's end-user friendly, but is still anchored and therefore get a lot of nice characteristics of what blockchain can bring. So let's get a little bit more into this. So we published a video about a week ago, I believe, about our vision of the future of content curation and distribution. Now, this video was created from the perspective of people who want to create content, who want to share with people they care about, and want to be a collaborative author in creating a future. And this little diagram here was showing how 3 people are sharing between each other, Patrick and Lauren and Edward, sharing content coordinated through a protocol. So I'm going to show you a part of the clip. In the YouTube, I'll link to the actual full video so you can actually see the whole thing. But let me just show you a part of it, and then we can go from there.
The platforms are ruled by large entities that are becoming more powerful and less imaginative. Content creators are forced to adjust their stories to these systems instead of enjoying the freedom the internet was supposed to bring. With Cardstack, we have a shot at turning the tide. Using the power of open source technologies, makers, storytellers, developers, and designers can come together to form decentralized networks, which allow them to create on their own terms. In the Cardstack framework, assets like text, images, audio, video, and even software code become very flexible objects, which we call cards. These cards can be embedded in and combined with other cards to tell larger stories. Cards are not trapped within a centralized system, but directly owned by the creators themselves. Others can review, reference, reuse, or remix cards to build new experiences, but the cards remember who deserves the credit. We achieve this by combining the best of front-end open web technology with a powerful open-source version control system called Git, which is then integrated with a blockchain to record permissions and history. That means any piece of content can live and evolve anywhere while keeping its relationships intact. Cardstack isn't just about...
So as you can see in the video we just showed now, we were thinking about using content creation and distribution as a use case, and then introducing this idea of Git combined with blockchain, Git being a version control software that is initially invented by Linus Torvalds, who is the creator of Linux, which runs most of the world now with his version of the open source Unix system, and blockchain as a way to kind of record this global rights. So in the bottom of the YouTube link, you see that we are talking about this being a Gitchain teaser. Well, what's the teaser for? It's a teaser for what I'm about to tell you. What is Gitchain, right? So let's take a look at that. So when we look at the word Gitchain, for the developers among the audience, it's probably very obvious to you that a Git, the protocol itself, is in fact shares a lot in common with what we know as blockchain. So I went to Wikipedia and I copied out this passage from it, which is that Git has this quality using something called cryptographic authentication of history. This is actually a section in there. So let me read it to you. The Git history is stored in a way that such that the idea of a particular version, a commit in Git terms, depends on the complete development history leading to that commit. Once published, it's not possible to change the old version without being noticed. The structure is similar to a Merkle tree, but with added data at the nodes and leaves. This is the Wikipedia entry for Git. If I change a couple of words, it sounds kind of like a blockchain. So in a way, Git is a cryptographical chain of hashes of history in a similar way that blockchain is a cryptographically authenticated history. So why is that so similar? It's because the way to make sure that you can keep track of revisions and version is to make sure that the new version always refer to the old version. But there's a little bit of difference. When we say Gitchain, we don't mean just using Git as a blockchain. We mean adding what's good about Git and what makes it powerful, what makes it the number one way where developers are collaborating to create really complicated software bundles and code, and in an open source way, both within and outside enterprises and on the open web. And blockchain, which is an imagination of new ways of creating this global marketplace or global commons that we talk about. But the one thing that we want to combine in bringing Git and blockchain together is Git has this very unique quality that whether it's developer or any content people starting to use Git as a content management system recognize, is that it's very easy to fork a repository, take a version of a piece of software or take a version of a HTML file and then fork it and try something else. And then if you like it, you merge it back to commit. Now, anybody who knows anything about blockchain knows that forking blockchain is relatively common, not easy, not necessarily desirable, but merging blockchain is beyond out of the question. We don't merge on blockchain, we just fork. But blockchain also create this opportunity to arrive at a consensus of a global truth, which is everybody can agree that this is the account balance of this address, or everybody agree that if you put this element on the blockchain, it will be there forever, and you can point to that timestamp and say that happens. Git doesn't really do that. So Git is actually something that is what I call a radically decentralized vision of a protocol. When Linus first did Git, there was no GitHub. There was no centralized authority of managing stuff. He's just basically everybody should have a version of Linux, and if you feel like having that version of Linux added to the official version, make sure that Linus merge your code that you've written using something like a pull request into his code base, and that becomes the official Linux. So basically, anybody can have a folder, but whichever one is on Linus's folder, whatever he chooses to include becomes the future version. So this idea of Git is that there's really no center authority. But by combining Git with blockchain, we can then say, the the world, the global truth exists where one piece of content, once everybody agree, is updating Wikipedia or updating an article, that everybody can just synchronize to that state. So combining the radical decentralization and flexibility Git with the type of consensus you get in a blockchain is what we're aiming to do. So let me get a little more concrete about what we mean. And the best way to look at this is to go back to the video, The Future of Content Creation and Distribution, and kind of tease out the word content creation and distribution and look at that separately. So let's use an example that has nothing to do with Git or any type of crazy jargon or blockchain. Let's think about just word processing. So when you create a article, in this case, the Ultimate Storyboard Experience article, you use a word processor, Microsoft Words or something like that, and then you create through that tool, the word processor, the creation process, something that is called content. And that content is encoded in something like a Word document, .docx. And then distribution would be bringing that document, that Word document, into a shared folder. And then this is a Dropbox folder. It could be a SharePoint folder, whatever it might be. And when it is synced or uploaded to the shared folder, it's considered distributed. That distribution also could be a mailing list or email, whatever it might be. So that's the basic idea of content creation and distribution. You have a tool to make the thing. It created an artifact, some sort of bundle of text, images, and stuff like that, and then you move that bundle into a place where it either become accessible to others or gets proactively distributed or notify people that, hey, you have synced it or push it down to a computer if you're synced to that Dropbox folder. So, but let's look at something that is closer to kind of modern web development workflow. So instead of using a Microsoft Word or word processor, use a web page editor. This could be a drag and drop editor, it could be a type, and it could even use code. But when you save a web page, it's not as atomic as a .x file. It's going to be a folder with HTML, CSS, and some JavaScript. And that's a folder that exists, that represent these interlinked resources that will allow you to render this special fare to visit Norway for $250. That seems like a pretty good deal. And then when you're done, and this is the kind of old web, you upload that folder to a web server. So visit Norway.deals. There's a FTP account. You just type in your username and password. You pay GoDaddy, a web host, $6 a month to $5 a month, and you have a web server. And that's how you distribute it. And that's been true for a long time. But if you ask the people who have been web development recently, what has really changed is this last part, which is instead of uploading it to a FTP server as a way to deliver this for distribution, the web page editor, which could be a web app, it could be a desktop app, still creates the same HTML, CSS and file. But instead of directly pushing it to the website by uploading FTP, you check in your code, your HTML, CSS to GitHub. Right? A Git repository, a shared folder system that tracks version history. And based on once you checked in, there's something called continuous integration, or CI, which automatically say, hey, someone checked it in, it's the official master version. Let me bundle all this stuff together and then deploy either to the cloud or to a server, and that's how this gets here. So that's how GitHub has got into the workflow of helping people not just keeping track of, oh, did I upload this file already to the FTP server? It actually has a version management system so that what you're working on locally is managed by Git, which is a version control system. Every single time you add a file, you keep track of what file you're changing, what items you're adding, what image you're editing, and when you push it, it's actually keeping track of that commit or that set of commits as an atomic thing. So remember what we said about Git as a chain. It remembers the entire history in a cryptographic way, so you won't miss a file, you won't forget a file. Everything has integrity when you push it up. And when you push it up, you're pushing it mostly to a service hosted by github.com, which is a great website that is basically where all the developers are putting the code there, networking there, and that's where a lot of the social network aspects of open source or even closed source development exist. But that's the idea here, is that GitHub becomes this clearinghouse of the stuff that gets created, kind of distributed onto people's computers and laptops with version managed folders managed by Git, and then they kind of help you as a single source of truth to deploy to whichever website, whether it's Visit Norway or if you work for a company, your own company website. This is a very common workflow with tools like Gatsby or even for statically managed website where people want to deploy. So, but I think it's probably worth looking at how GitHub actually gets structured, right? So GitHub sits at the center. So there's this octocat. So they're literally with the little round cat, octopus actually, cat octopus mixture sitting at the center. And then Git repository is something that exists so that creators, people who are making things, coders, checking stuff, are just updating the Git repos. Sometimes they update on a computer and they push it. Sometimes they're updating directly on github.com. And that information gets sucked into GitHub, and that's where the workflow begins and where it goes next. But I don't know if you guys remember, but Microsoft bought GitHub, the company, for $7.5 billion because that is a very powerful network of people coming to the center, centralized infrastructure of GitHub, to do not only coding, but increasingly collaborating on content, collaborating on data set, collaborating on specifications and documents and rules and regulations and collaborating on legal clauses on GitHub. That's all great, and I think it's healthy that GitHub is a great organization, and Microsoft is probably the most respected organization in open source in the way they support creators, about support projects and being very open to that. But topologically, especially coming from a kind of decentralization, blockchain type of orientation, that seems a little bit uncomfortable. Like, does it make sense for everything to reroute to this thing? Especially if the original version of Git, my folder, your folder, I put something on your folder, is very decentralized in the way Linus intended for it. So what really got us thinking is that if this was a donut, could we hollow out the center? Could what GitHub, this important position exists in the center, be replaced with something that is more like a protocol, less like a service? And that's where Gitchain came from, which is allowing us to find a way to allow creators to connect with each other using something that's a combination of Git protocol and a blockchain system so that they don't need a centralized entity as a coordination of what they do. So let's simplify this a little bit. So let's just look at two different repositories. So one would be owned by one person, and the other one could be a company, or it could be a partner, or it could be another person. So I hope I have convinced you that almost anything that is a file, right, can be managed in a Git repository. So this is content that's in HTML, content that could be in some JSON or format, data that's in CSV or data in some JSON format, and certainly code and JavaScript and markups and configuration file. These are all files. And these files can be checked in to a Git repository the same way they can be copied into a folder, except Git will keep track of every change to every file and build up this content addressable system that allows you to be able to go back to a previous version if you made some changes or deleted a file and you say, oh, I want to go back, and that's what Git would do for you. Git is useful without pushing this to anybody else, just as a way to manage your own content. But let's say you want to make this set of things, your website or your proposal or whatever, your data set, available to another person. Right now you have to upload it to GitHub, but with Gitchain, you can push it to Gitchain. Let's talk about what that is in a second. And then the Gitchain will carry it through, right, the whole bundle, everything that's in it, and allow another Git repository, another client, another computer, another server to download all the information to recreate the content, data, and code and have it show up on the other side. This is what we call synchronization, right? Syndication and synchronizations are pretty similar. I would say the syndication have more rules determining what you can do with it, but if you're just making a copy of the whole thing, then it's basically synchronization. So I hope that makes sense. Gitchain has a hollow middle, and it just routes around the boundary through the concept of a distributed network. But let's be a little more concrete of what is the moving parts of this distributed network. So same diagram, pushing and syncing between two repos. But here we have two really basic set of infrastructure that underlines what we call Gitchain. One is a distributed storage. If I put a 400 meg file, I'm not going to put that into the blockchain. That's just not going to fit. So I'm going to put something along with all the changes and metadata and caption and description, whatever I want to do, into something called pack file. So in the Git protocol, or the Git software that the protocol and most people use, there is, every single change is stored in the folder structure in some way, but that's a very inefficient way of moving large amount of things around. You have to copy 4,000 files or 40,000 files. So you can create something like a pack file, which is not all that different different than a zip file, but it's in a way that's compliant to the way Git works and the way they want to be efficient in doing things like that. And once you have a pack file and you put it in distributed storage, and that could be a shared drive, it could be on the cloud that you can access, or it could be in a distributed file system like IPFS or other type of kind of blockchain-driven storage system. But once you have the pack file, then you have to tell someone that where this pack file is, and that's where the reference comes in. You put a record on the distributed ledger, which is quite limited in size, but then you say, hey, whoever finds this link in the distributed ledger, just go and find the pack file, and then with the pack file, you can recreate it. So it looks something like this. When we push, we create the reference on the ledger. When the other person sees the reference, they go and look up the pack file, download it through a distributed storage mechanism, unpack the pack file, and maybe previous history of the pack file, so you may have to go all the way back to the root, and then you can sync and recreate a Git repository. The great thing about that is that what you end up doing is making a copy of that original content data and or code, or mixer of three, in a new repository. The whole way of figuring out how to pack the pack file, how to decode it, how do you reconstruct history is already done by Git. This is a protocol has been pushed and iterated on for all this time. There are different implementation of it, and it just works. Like developer relies on it to make sure that every single line of code that exists in one repository shows up on the website precisely. And that's not an easy thing to do. So instead of creating our own protocol to synchronize distributed ledger and storage, why don't you use the one that has been proven all this long? So that's what essentially Git, the protocol, is doing for you, is to figure out how to unwrap these pack files to create a very consistent folder structure. So that's the moving parts. The key here is that we are only solving a tiny bits of data on chain. More importantly, we are storing a consistent amount of data for each of these pushes or these pack files, because we don't need to store how many files is involved in it. We don't need to store how many changes were made, how many people made the changes. All that information is basically condensed together in the Git protocol through the pack file. All you have to do is to tell me where the pack file is and maybe a little logic of who can access it or such and such. The majority of the data is considered off-chain, which is not on the distributed ledger, but it can be in a distributed storage. This distributed storage can handle megabytes, gigabytes, in some cases terabytes of data. And if you chop up the pack file more, either naturally or using some other mechanism that's in the storage space, you can theoretically store any amount of storage off-chain, and just using that tiny bits of on-chain data to recreate the instruction for each of these Git repository and the Git software running to recreate that content, data, and code. So this is another way of looking at the same thing. So we have our distributed ledger or blockchain layer. You have the distributed storage layer. Both of these are considered layer 1 protocol, right? They sit on the bottom of this thing, providing a ledger service, providing a very flexible content addressable storage service. And your Git repository is really an abstraction that sits on top of that allows you to go and open up the folder instead of inspecting the blockchain or looking into a pack file, and you can see things clear text. So you can just look at what's inside, not all that different than downloading a zip file and seeing what's inside. This layer is what we call the layer 2. This is the distributed sync and syndication system, right? Using Git as an online protocol to select that. So these are the 4 things involved. When you write a bunch of files, you want to pack the things together and connect the version via hashes, as the Wikipedia article suggests, and then you upload the pack file into distributed storage. And once you know where it's going to be, then you record the hash and the URL to that pack file on chain using a distributed ledger. And then, when you are a consumer of this Gitchain transaction or this syndication or synchronization, you want to look at the reference and say, where's the pack file? Find the pack file, and then download the pack file, unpack it, right? And that's how you can accomplish those movements we talked about using these 4 operations. And then this layer 3, which arguably is that layer 3 or layer 7, doesn't really matter, is that the users had to be able to see what's in the Git repository. And I can tell you that most developers are, hey, just go to my GitHub and check out what I do. And the Git stuff and the text files and the code makes sense to developers. But if you're not developers, you have no idea what that thing means. And it could be as simple things as like a list of website to blog or something, or a list of articles or books to read, but people don't know how to look at, markup like HTML or JSON. So what Cardstack has been thinking about, and this is in our name, is that why don't we represent these bits of information that's in this kind of distributed storage, the Git, as cards, so that we can, when you create the card, we will then take the data in the card. You're filling out a form, you're creating an article, whatever it might be in the card, or creating some metadata about video. We save it and then save it as a file in a Git repository. And then it goes all the stuff on the bottom. And then when you want to be able to display this article, you can use the Git repos. It's just like, hey, what's the article title and description? And then translate it to something that's much more friendly, much more like a small web page or a little widget. And blob is a binary large objects, is the actual media itself. That could be in a Git repository. Certainly that can be part of it, or it could be referenced as another thing that's stored in a distributed storage that's stitched together by this user hub. And that's what actually Cardstack does. And the idea here is that these cards can represent data, it could represent content, podcasts, and stuff like that, or it could represent code, or some logic, or some rules, or some actions. And that's a lot of the work that we've been doing in Cardstack is about building this layer 3, but we have always knew that we have to go all the way down to layer 2, the sync infrastructure 1 and 1. And that's why we're using this infrastructure of Git as the underlying foundation. Because what ended up happening is that you can now use 4 technology together to build something fairly sophisticated. So we just finished a project where we helped a large label and a large publishing company manage the metadata about their songs and their recording and the musical work and their artists and even the audio file in a way that allows them to version and change. So someone made a mistake in misspelling something, they can do a new version. And to put that on a blockchain directly, not only is impractical because there's so many fields, so many values, putting 100 or 1,000 value on the Ethereum blockchain takes a few hours if you were to just send that in one at a time. So it requires us to do this packing or this reduction of the number of records that you need to put in a blockchain. So if I want to upload a music catalog or upload a content catalog of 50,000 files, I only need to make one blockchain transaction pointing to a pack file that contains all those changes. And we use Cardstack as the UI layer and also the data orchestration layer. We use Git as the underlying way of versioning it. We actually store some of the stuff on GitHub so we can see as we're developing a project how that's looking and inspecting it and having something. And we use S3 to store the pack file. That's cloud storage. And we use Hyperledger Sawtooth as the blockchain to synchronize these references. But here's the cool thing. Once we've built this infrastructure, if someone say, hey, you built this really specific thing for some enterprise and stuff like that, could I use this to build a decentralized app, a dApp? Is this Cardstack plus Git plus storage and ledger scalable or, more importantly, flexible to support other chain? And the answer is absolutely, because Cardstack Hub has this plugin mechanism. Instead of storing in an S3, it can store in IPFS. The great thing is we didn't even build that. We used a library that abstracted a way to store these pack files or any file to whether you want to store it on S3 or IPFS. It's just a different credential. So we can do that. And then we're working on porting all the code that we are using to keep track of things in a private blockchain and move to Ethereum. So if you want to say, I want to publish this thing to Ethereum and I want to have something in IPFS, we can help you synchronize that. So this is what we call the public network option. And if you want other storage mechanism, such as Sidecoin or whatever it might be, or Filecoin and becomes a thing in the future, you can certainly change just the adapter between Cardstack and those protocol and make it happen. And then Ethereum, obviously, are going to shift around. Like there's be 2.0, there'll be a different chain, the new Plasma chain and Parachain. These are all things that you can leverage. Depends on what kind of security you want, what kind of network existing characteristic you want. You can choose a different ledger or blockchain as your bottom layer as you want to build up your network. One thing to note is that I've both looked at a lot of projects from companies that have done hackathons. And one of the most common things you see is some people doing some decentralized finance, like using programmable money and doing something like that. But a lot of people building up blockchains are actually pairing IPFS and Ethereum. The big stuff, the user state goes to IPFS, and some people put a database abstraction in front of it. There's a couple of teams working on that. And then Ethereum is where the official stuff happens. But all of them requires this correlation, and sometimes they get out of sync. Gitchain is extremely precise because Git as a protocol has this kind of hash history. And we peg that to the blockchain history. You would never be out of sync by even 1 byte. And that type of precision versus, oh, I'm using a key value store here and I hope this matches up, reduce the amount of error that you're going to get from the end users. So we feel like using Git as the way to combine IPFS and Ethereum actually is something that I think we're pioneering that work, but I think it actually makes a lot of sense because it allows developers, especially developers that understand Git, which is most of them, to actually rely on the knowledge they know as they think about how user data are actually captured, stored, isolated, and shared. Git provides a very good foundation, not only for, let me store everything in Git and put it on Ethereum, but also let me not put this on the chain because it's private data and then take a subset or merge it into a repository that is more public or much more shared. And that type of isolation using the different repository to reflect different organization boundary is something that's not really possible if you're just saying, I'm putting everything in IPFS, which is public, or I'm putting everything in Ethereum, which is public. So I think Git provides this additional granularity of trust that would be very nice. And Cardstack will support a lot of these patterns of access control natively in our support for Git. So we have an application that we built in March to showcase what we call an article card. So Cardboard is an open source web publishing system. If you go to github.com/cardstack/cardboard, you actually see a version of this. This is a slightly refreshed design, which we'll be rolling out soon. And we have a concept of an article card. So it's like the web page that I talked about earlier in the content creation distribution side. This is a article card can contain some text, some images, and that bundle is stored in Git. And that's essentially what we wanted to do, which is like while we're building Gitchain, figuring out how Gitchain connects to the blockchain, how it can communicate with the app, we wanted to not care. Because all we care is that we're storing it in a folder and that folder is managed by Git. Each article, each the text is actually checked in. You can go to Cardstack/cardboard -data on GitHub, and you can actually see the article broken down as these files. They're not HTML files, they are JSON-based files, so we can reconstruct the database from by traversing the linkages between the articles and his tags and his image references and create something that will basically form an API so this article can render all the things as, you know, on this beautiful snowboard trip. And we started building it on GitHub. And I think people are wondering, like, you know, why are you using GitHub? It's because GitHub is a really good scaffolding to get our Git implementation and our Cardstack implementation that interpret those Git results in a way that shows people, hey, here's a Medium clone, or this is something better than Medium because you can theme it and you can have different modules and stuff like that. So we wanted to have an application that we can test so that we can have an application to test Gitchain with. And that's what we're working on this week. With Gitchain being used in this kind of private network for the work that we've done in the music vertical, we're now importing that to support this open source web publishing system, and then using that as a test bed for us to go and say, hey, all of this stuff is not going to go to cloud storage, it's actually going to IPFS and Ethereum. And that's the work we're actively doing. The great thing is the application on top doesn't have to change at all. And then if you are a developer or you want to say, hey, I like Cardboard, that's a great CMS, or I want to use that to build up a podcast system or some interactive narrative experience, you can choose whether you care about decentralization or not. If you want to use the Cardstack full support for the GitHub plugin and the API, you can use that. You can just imagine Gitchain doesn't exist. But if you're into decentralization and you want to use the Git protocol, but in a decentralized way, you can just flip a switch and use Gitchain, and then your article is being syndicated around the world without being in a central place. And that also obviously applies to data system, you know, CRM type of system, or even messaging workflow system, which is another thing we're working on. And I'll give a talk on next week about our use of this Gitchain infrastructure to build a very interesting workflow system that does not require a central party. But it's all about providing ability for people to exchange data. To do it one step further, we actually were using a module within the Node ecosystem called NodeGit, which uses the Git runtime as a piece of native software that's wrapped in Node.js so we can access it. But we found this amazing new implementation of Git, which allows people to basically run a Git client in Node.js, in native JavaScript. So he re-implemented the entire protocol in Node, so we don't have to deal with this native dependency of C code and compiling them. It's actually just Node.js code, but it also runs in a browser. And I think this is amazing, right? So if we're using Git protocol as a way to pack and unpack and stuff like that, wouldn't it be great to have a situation where your cards and the Cardstack runtime just runs in a browser, but provides this additional service beyond just what MetaMask plugin or Web3 plugin gives you, because Cardstack give you indexing, give you authority to do security control, and give you the ability to do composition data, merge multiple data streams together. Currently, Cardstack runs on a node. And one of the reasons is because the old version of Git we're using were native code, so it has to run in a server. But with isomorphic Git, which we're switching all our Git work to, now we have the opportunity to run really well in a node ecosystem, but also allow us to add features to it. And in fact, one of the APIs we added to the isomorphic Git through a sponsorship through Open Collective is to add a pack file support, so we can replace our zip file approach with a more compliant pack file. And that's a great collaboration when everything below us, including Cardstack and the app we put on top, is open source. So excited to bring isomorphic Git to more people through the Cardstack experience, to see the Git protocol going beyond its niche of being a programmer's tool, but actually as a fundamental protocol of the type of work that we want to do on sharing on the web. So zooming in a little bit, one of the things that Cardstack has been focused on is this layer of app-like creation and curation tool. So when we talk a lot about the Cardstack application framework, it's about building the app or helping developer figuring out how to build the app. And the only way to explain what the Cardstack application framework is to say we're trying to build a new type of building with a new type of material. It could be steel beam, it could be carbon fiber, nanotubes, whatever it might be. Cardstack is thinking about building application in a new way. And the only way we know that building technique using the card-based approach works is to build test application on top of that. And we built one in the kind of decentralized finance cryptocurrency space called Cardfolio. We built obviously the data application that we've done for the music companies, Cardboard, which is a community content management system, and 4Edges, which is a more card browser. So you can look at the cards, you can queue cards to be sent to other people in a more generic use case that any app can tap into. Those are the things that give us confidence that our app framework is working. And the more we build these kind of apps, it helps us validate the framework. Our hope is that once our framework is solid and we have a standard set of things that you can use and know how to send a message, how to do an article, that people will expand it the same way you make a basic blog in WordPress and people add a plugin and make that richer and richer system. But the only way we know that the application framework is solid is to build apps and test out all the APIs we have, and we're iterating the API, making improvement. But we're very, very close. We feel very, very confident of being able to provide that app area of this three equal parts architecture. Gitchain is actually one of the first and probably one of the most important part of the second part of what the Cardstack architecture is about, which is allowing people who build on top of Cardstack, build on top of application framework, to be able to use the card concept to build networks with each other, to build relationship, right? And Gitchain, as you can see, because almost all the things in Cardfolio, your wallet, your portfolio, Cardboard, your article, and images are actually encoded in Git. So it makes sense that the syndication and synchronization of that is using this standard way no matter what it is. It's a very general purpose protocol for moving things around, and it just so happens that everything that we have designed it's been sitting on top of Git, and therefore we can use Gitchain as the primary way to build this next generation network. I'll get into more detail in the future talks about how that fits in, what kind of workflow that we can accomplish for sharing or lead generation, even getting a lead and then distribute it to multiple people. That you can only get if you're participating in the network, and Gitchain will only distribute it to the people who are part of the certain DAO or decentralized autonomous organization. So these are all the things we can do. But one thing that is I get a lot of community questions through our community moderator is, what is this all going to lead up to in terms of the revenue model and value distribution of this ecosystem? And the idea here is that most people in the cryptocurrency or blockchain or token project space has been focused on this revenue part, this value part, this programmable money part independent of application and network building, or the application is to support the token model or the value model, and the networks are because you're participating in value model. I believe that there's a huge amount of content from e-commerce to CRM to lead generation to customer service. Those are all type of application that would benefit from the global consensus and this distributed protocol that blockchain can provide. Not all of those people, I would say 99.99% of the people that will use an application, a Web 3.0 application that's backed by blockchain, has ever own or possess or hold a token. But they may want to be able to put something on the blockchain, and they want to be able to pay the fee as they put the thing on the blockchain so that their transaction doesn't fail. And they have never heard of Gwei, they have never heard of gas. How does that all work? And that's essentially what we are trying to do with the card token, which is if you have a balance on your card, $100, $5, that becomes a balance that when you're putting something on Gitchain, and therefore you need to put 10 cents worth of gas to put that and register and reserve your little space in the global ledger of Ethereum to make sure that your content or your data set has a record in this global ledger. You can either go ahead and find a way to buy 10 cents worth of gas, or you can say, hey, whoever is willing to honor this transaction, you can deduct 10 cents from my balance, right? My prepaid card. And then, the network will pay you hopefully 11 cents or 12 cents. And that's essentially what we believe the thing that's missing in the blockchain spaces, which is, what about utility? What about users wanting to use it without ever seeing it? Having a balance that they can buy with a credit card, they can subscribe on a monthly basis, and then having that value, right, that subscription or that prepaid value, be distributed evenly and as used with trust when someone helps you put something on the Gitchain or someone help you put something on the file storage network operating by Filecoin without having to touch the token. And that's very, very different than just say, I want to hold the token and I want to kind of, look at it. It's actually just about paying the fees across network. We see card token as a universal fuel, as a way to be able to trigger the correct transaction to allow you to do all the other things. So we have a lot of things planned, and we'll get to more detail about the clutch mechanism, which is a way for you to purchase token using a credit card that you can't trade. You can only give it back to the network, handing over the token so that someone can basically fulfill your request to do a set of operation on chain for you. Card key is our way of signing transactions so that you can sign transaction without having to deal with wallets and key phrases, all about making the signature process of signing a transaction as easy as just signing into a website without having to worry about all the stuff that we have to deal with today with hardware wallets and recovery phases. And Tally Protocol is all about starting simple, looking at what transaction has happened, who has paid for whose gas, and then being able to use Cardstack Hub as the computation and say, hey, you should give this portion of these balance that has been deducted to this person because he's facilitated 4,000 transaction last month, and this knows facilitated 3,000 transaction. But in the future, Tally can be augmented beyond this basic counting and aggregation to start making some judgment call of what portion, is there a bonus, is there a penalty based on good or bad behavior or latency or speed or reliability. So that's kind of the whole idea of how you take this pool value of when people are actually paying to use this blockchain-backed software, how that value can go back to not only the people providing the service, but something dear to my heart, to the developer, designers, and makers who are making this experience possible, spending time and energy to create the card, create the UI, create the widget, create the theme that makes your content or your application successful. So that's the architecture in 3 equal parts. You will see more coming from the Cardstack team on the network relationship and the revenue model value distribution. Now that we feel very good about our application creation tool and being able to kind of condense our idea into something that would be a more easy on-ramp through documentations and sample apps and a standard card set for users. So to summarize, what we've talked about today is this important protocol that we've been working on along the way. I think the first idea of Gitchain started almost 2 years ago, predated a lot of things, and because we were in Git and with in blockchain, it just was a very obvious thing. But we want to be able to show you guys everything end to end running. So the current version of Cardboard is on GitHub. So the data is stored into GitHub in something called Cardboard-data. But we are using that same as a kind of test case to move it on Gitchain, and hopefully within the next couple of days, if not the next week, we'll record a demo of that working on Gitchain using the permission network level version, but then that will also become the code base that we'll use to test the Ethereum Filecoin IPFS version. And then a lot of people are asking me, where is all the Cardstack code? We oscillate, right? Sometimes we have the Cardstack framework in GitHub /Cardstack. Sometimes we work on that very intensely, and we work on these other applications. Sometimes we don't open source them to the end, like Cardboard and stuff like that. But we are trying to put more of our code into that mono repository, including the basic standard cards that comes with every Cardstack installation that end users can use right away and developer can right away. So that's a repository to look for. More things will go here. The Gitchain will also be kind of packaged there. So I will give more detail on what is the card catalog we're working towards, what are the standard cards, what can you start with, what is our equivalent of blocks and users and tags and stuff like that. It's going to be a very interesting thing to that. Our Q2 planning meeting, which happened about 2-3 weeks ago, was about kind of figuring out what would be not only the improvement to the framework that we're going to do in this quarter, but also example apps and standard cards that user can play with. That's very exciting stuff. And then we also have a recognition that with synchronization, you're just making one repository exactly the same as the other repository. But a lot of times, the most interesting thing in the world is, submitting, you're a writer, you're submitting one of many articles to publication. You're not going to sync the whole folder of all your novels and novelettes to do that. So we do something multi-Git. This is a protocol that is kind of sitting on top of the different Git repository that allows us to selectively share different portion of what you have worked on in Cardstack with other parties by creating new repository that's shared between 3 or 4 people if you're working together as a team, or having inboxes where you can submit things almost like a competition into a box, and it will filter within the organization by moving or promoting those cards or those Git resources around. And this is a really important enablement for decentralized workflow across that has no intermediary. So you're not like just putting everything into one Google website and have Google route things. It's actually moving these files from one node to the other one, jumping around. Now, obviously, all of them will run Cardstack, so we'll not only speak the protocol of blockchain and Git, but also understand relationship. Oh, I'm sending you my article, but my original file is really, really big, and you can get a low resolution version, but then when you, let's say, pay for my article, you want to go publication, then you can get the high resolution version from me. These type of selective sharing and selective permissioning across these multi-party workflow is what we call multi-Git. And F-Walk, the lead developer, our teammates working on a request for comment soon on how that will work. So this will build on top of the work that you've seen as in Git. So this is a quick update. It's quite a technical one. We weren't actually planning to make Gitchain a thing, but with all the conversation I have with even some of the people in the cryptocurrency space and the blockchain space, they were very interested in this. They was like, hey, the thing you're doing with Git and blockchain is really interesting. So one day we just decided, let's call it Gitchain. Let's give it a name. Let's make it a real thing. We're going to make a website. And then you can go and look at Gitchain separately. We hope this is useful, whether it's for someone building kind of more kind of end-user-friendly application that's not in the decentralized finance space. There are a lot of use cases that we feel that Gitchain is a very good, appropriate work for. Obviously, if Cardstack helps as a way to make Gitchain even easier by generating an API and giving you a template and giving you a style sheet and a design system to make your app come alive faster, I would love to introduce you that to as well. But I believe that Gitchain is an accidental discovery, is what our developer who worked primarily on that told us. And but it's a good thing to be able to make into an infrastructure that allows us to build end-user-friendly application that taps into the spirit of the open web and allows us to connect the blockchain vision to the reality of what people aim to do every day. So thank you very much for your time. I hope this was helpful, and I will update you guys soon with other updates on technical and design and all the efforts that's going on. My hope is that this can become a weekly thing, and hopefully it becomes a glimpse into the amazing work that our team and our extended team is doing every day here. So thanks very much. We'll talk soon.